Okay, back with some more ALEKS examples. And what we're going to do for these particular ones. And again, I can't do every type of problem here, but what I'll do is kind of pick a few of these. These are all going to deal with probability. And you'll see here, there's some sort or element of counting that needs to be involved because again, these are referred to as classical or you know, uh, theoretical probability. And we set the scenario here, and it's just, again, I know it's frustrating. We're talking about bags of marbles here. What does that have to do with collecting data? Remember, we're building that house of probability, or I should say, inferential statistics, and on the base floor is probability. So we're kind of just focusing on some of the general principles here that we'll be applying later on to collecting data. So this is just something we got to weather for a while, and once we move past it, we'll get into some more, I should say, into the interesting or applicable parts of this. So with that said, let's jump into this. We have here a bag of marbles here. I'm sure everybody has a bag of marbles laying around their house somewhere. And in that bag, you can see very clearly there's 5 reds, 3 yellows, and 4 blue marbles. And so they're just going to give you a simple question here. What's the probability that it's red or yellows? Now, I don't need, permutations or, combinations to count anything here. It's just as simple as looking at the diagram here. And actually, they even give us the numbers here. There are 12 marbles in the bag. If I wanted to count them, I could. So that's my sample space, right? We're just drawing one marble out of the bag. And therefore, we have 12 possible outcomes. Now, of those, we are interested in red or yellows. So all we would have to do is add all those up. So again, we're counting. We can sit here and look at them and count them, or we can just add these numbers, whatever easier way, whatever's easiest for you. And you can see that we end up with 8 out of 12. And I like how they do not reduce the fraction. They don't say that you have to here. And I think it's a lot easier if you don't. But it would be perfectly fine to express this as, what do we say, 3/4, right? If we cancel out the 4 or divide out the 4 out of this problem. We would, or I'm sorry, excuse me, 2/3, excuse me, 2/3. Or we could, express it as a percentage and that sort of thing. So if it's 2/3, that would be, what is that, 66%, somewhere around there. So, but again, just go ahead and express it like they have it here. Don't worry about, simplifying unless they tell you to do that. Again, that's one of those ALEKS things, okay? Okay, so, that was just, an introduction here to probability. And now if we get into something that might be a little bit more, involved in terms of, what we're asked to do here. So we have 6 balls, 1 through 6, and one ball will be randomly picked. So again, we don't have a diagram to look at here. And, the problem is just, I know it sounds silly, but I think everybody remembers what a multiple of 3 is, but they might use some mathematical language here where you got to think or look something up. So here our possible outcomes again are 6. So that's going to be our denominator. There's 6 possible outcomes, and a multiple of 3 of those 6 outcomes. Well, 2 of those numbers, namely 3 and 6, are multiples of 3. So this one should be 2 out of 6, which it is. So again, pretty straightforward there. We have here, if we get into complements, and the other problems are just like that. I don't know. I guess these are going pretty quick, so I can do a few more. Watching the movie here, he has 3 action movies, 11 comedies, and 9 dramas. So he's going to randomly select one movie. So again, we know that we have here a total of, looks like 23 possibilities. Something that's not a comedy, okay, well, I would just add up the 9 and the 3 here. There's different ways of looking at that, but that's just literally going to be the 12 ways, right, that aren't comedies. And, we don't have to distinguish, between action and drama. They kind of group these together because these are both not comedies, these types of movies. And so therefore, that would be the 12, right? 9 plus 3 is 12, and then there's a total of 23. Okay, so okay, so when we deal with complements there, and that was kind of a compliment, right? Because you know, uh, something that is not a comedy, okay, would be the complement of a comedy. And so if I would, go ahead here, this one looks a little bit more complex here because they have this table here. Okay, so now it's important here that they emphasize here these sections are equally sized, and therefore each one has equal chance of being, the wheel stopping on those spaces. And we'll assume that there's some sort of clicker here that won't allow it to stop on the line. But they have gray spaces and white spaces, and then all these numbers here. Okay, so it spins the wheel we're spinning, it stops on random, on a particular slice, and let X be the event that the wheel stops. So they're starting to introduce some probability notation here. So we can look at this as a random variable, right? This variable X is going to be determined, again, by what that outcome is. Okay, it's the value of the outcome. And so if I again go ahead and see which ones satisfy this one here, it says let X be the event that the wheel stops on a slice that is not white. Okay, well, one that is not white, okay, I would mark all those. That's the 1, 2, 3, and the 5, 6, and you can see, and also the 8. So I'm just kind of, checking these things up. And all you have to do is, this table is just a way of organizing here, what all these outcomes are. And so, we're more concerned here with not the number, but the color of the wheel, as it being either white or gray in this case. And so now we want the probability of it not being white. Well, there are actually, again, as we said down here, 6 of those that are white or not white, and 2 of them that are white. Okay, so now it says for each probability here, because again, X is, not white. So anyway, so if I go ahead here and figure out this probability, the probability X is, all I'm going to do is just take out of all the 8 ways, 2 out of those. Now they do reduce the fraction here. We've got a 2 out of 8, which reduces to 1/4. And then over here, we have 6 out of 8, right? So if I counted up the 6 here, so if this were a 6 and an 8, that would reduce to 3/4, okay? So that's how we find these probabilities. Again, X, let not X be the event that it is not white. And so therefore, by default, X is the event that the wheel stops on a white slice. They define that up here. And P of X is the probability of that event happening, okay? And you can see one of the things they're trying to emphasize here, that an event and its complement, if I consider the probability of an event and its complement, they're always going to add to 1. So therefore, I can always find the probability of the complement or the event by simply just taking the one I know and subtracting it from 1. So for part, B here, they just tell us to subtract this and we get the 1/4. And therefore, they're kind of, it's not a proof, but they're just illustrating here with this example that 1 minus the probability of a complement is the same as the probability of that event. I could just as easily say 1 minus the probability of event is equal to the complement as well. And it's just going to depend how they word this stuff here. Okay, so what distinguishes this problem maybe from the other ones is it starts to get into some probability notation, this idea of probability and then parentheses, and typically we'll put the events in here. Sometimes we put variables in there to represent phrases. Sometimes those variables can equal numbers. It just depends on, what those outcomes that we're interested in. Later on, we're going to talk specifically about putting numbers in here and those variables taking on number values. But here it wasn't. It's just X is the event that it stops on a white slice. Okay. So there you have that as far as complements are concerned. And I'm going to end this video here, and we'll be back with some more examples.